Good morning, grade 7s. My name is Sisego Tuli, a teacher from Reference Primary School. Today, guys, we will be doing common fractions, but focusing on adding and subtracting of common fractions where one denominator is not a multiple of the other, but not limited to mixed numbers. Right, class? Now, let us start. Alright, guys, I've prepared few items that we've got to go through before we can take on our lesson for today. First, I've got concepts and the skills to be achieved by the end of the lesson. I'm hoping that, guys, at the end of this lesson, we would have learned something. Alright, my concepts are as follows. Learners should know and be able to identify common fractions where one denominator is not a multiple of the other. That is our focus for grade 7. Calculate common fractions where one denominator is not a multiple of the other. Simplify common fractions. Simplify improper fractions. We're going to touch on improper fractions as well. Differentiate between a common fraction and a mixed number. Then lastly, calculate and find the sum and differences of mixed numbers where denominators are not the same. Right, guys? Let us now identify the prior knowledge that you guys come with from grade 6. In grade 6, we did compare and order common fractions, including specifically tenths and hundredths. Grade 6, we did add and subtract common fractions, including mixed numbers, limited to fractions with the same denominator or where one denominator is a multiple of another. That is what we did in grade 6. And we also covered the part where we were supposed to find a fraction of a whole number. So let us begin. Let us take a look, guys, just to remind ourselves what is a fraction. Just before we can embark on anything that has got to do with a fraction, we've got to understand what is a fraction, or remind ourselves, because I believe we have done fractions since grade 4, grade 5, and now in grade 6. There is something that I took somewhere for you guys, just as a quick reminder for us. Let us take a look at the following video, just to remind ourselves what a fraction is. It might add some value to us as we go along.
Sharing is caring, but when it comes to chocolate, no one likes to share them, isn't it? When you share something or divide something, there is a lot of mathematics behind it. So, without wasting any time, let's start this session with you and some of your friends. You and your 2 friends went to Ben's house. All the while waiting for you guys, he ate 9 out of the 10 chocolates that he kept for you guys. Now, after you guys reached, all you have is one big chocolate that you have to divide it in equal parts among your friends, including Ben. No cheating. So, how will you do that? Nice. You have divided one whole chocolate into 4 equal parts. So, each one of you will get 1 part out of the 4 parts of the chocolate. Or, can we say that each one of you had 1/4 part of a chocolate? And numbers in this form are known as fractions. So, what is a fraction? Fraction to a layman is just some part or a piece of something. The numbers of the form a by b are called fractions. Let's learn something more about fractions. As we can see, a fraction has 2 parts, one top part and one bottom part. The top part is known as numerator number of equal parts which have been taken out or which have been left out. Like as I said before, the numbers of the form A by B are called fractions, where B cannot be 0. But why will it not be 0? Because if it is 0, then the fraction will not be defined, as we cannot divide anything by 0. Confused? But why denominator cannot be 0? Basically, what is denominator? Denominator is the total number of equal parts in which the whole is divided, right? But if we cannot divide anything into 0 parts, we cannot give any part to anyone, and hence denominator of a fraction can never be 0. This is one of the golden rules of mathematics. Now, suppose your uncle asks you how much chocolate you had. You will not say you had one big chocolate, you divided it into 4 equal parts and ate one part of it. But now, as you know what fractions are, you will proudly say you ate 1/4 part of the chocolate. Now, can you tell me how much part of the chocolate did all your remaining friends have? 3 parts of the chocolate were remaining out of 4. So, they all had 3/4 part of the chocolate. Let's take a small quiz before we move ahead. Can you tell me that to the shaded region correspond the fractions displayed? In question 2, the shaded region represents the fraction, but not in the other two. Can you tell why? In figure 1, it is not divided into 2 equal parts. And in figure 3, it is not divided into 4 equal parts. And hence the fractions are not corresponding the shaded regions. Did you get all 3 correct? Let's take a step further, learning the various types of fractions. As you guys will eat, Ben ate 9 out of the 10 chocolates. Imagine if Ben had 100 or 1,000 or 10,000 chocolates. So here, the fractions which have the denominator as 10 or higher powers of 10 are known as decimal fractions.
Right, guys, welcome back. All right, from the video we have seen, I believe that we have already, it was a quick reminder for us on what fraction is and how do we get fractions and how we can call fractions fractions. Right. Now, here on the screen, I've got common fractions, 3/5 minus 1/10. And the other one is 3/5 minus 3/8. Now, let us take a look. The other one was 3/5 less 1/10. And then on this other side, we had 3/5 less, let me just go quickly back, right, 3/8. Now, when we check these two type of fractions, we can see there is one which is common to us that we have already covered in grade 6. Let me call this A and this one B. Now, when we look at fraction A, or the fractions on the side A, we have 3/5 minus 1/10. Now, when you check the two denominators on these fractions, we can see that one of the denominators is the multiple of the other. Meaning, between 5 and 10, one of them is the multiple of the other. Therefore, this part is what we have already covered in grade 6, whereby our objective was to make denominators to be the same. Let us go back quickly, guys. From grade 5, we dealt with the fractions where denominators were the same, e.g., a quarter plus 2 quarters. So the main thing that we learned from grade 5 was that we cannot add denominators because they represent the number of parts the fraction has. So our focus is only on adding the numerators, whereby now we'll say 1 plus 2 equals 3. But now we cannot add denominators, so our denominator will still be 4, meaning that our answer was 3 quarters. In grade 6, things got different. We had now to add fractions where denominators were not the same, number 1. And also, but the nice thing was that one of the denominators was the multiple of the other. So our mission was only to focus on making this denominator to be the same as the big one, or vice versa, depending on the situation. But in our situation here is that we have to now say, how can we make this 5 to be this 10? Now we go to our basic principles. We either add, multiply, divide, subtract. But with fractions, we only focus on multiplying or dividing. And one thing that we cannot forget is that what you do on your denominator, it also must be done on your numerator. So we can see that on the 3/5 part, our mission is to only multiply this denominator by 2 so that it can get to 10. But the way in which we should do, first step is that we open the bracket and then we say multiply by. Remember, we said whatever that we're going to multiply our denominator with, it has to be multiplied also by the numerator. So we'll multiply by 2 to get this to be equal to the denominator on this other side. But on this other side, we are going to leave a fraction as is because we want to make sure that the denominators are the same before we can add numerators or subtract numerators. So after having done that, now we work our brackets, Bottom's rule. So we say numerator by numerator, 3 multiplied by 2, it gives us 6. And then 5 multiplied by 2, it gives us 10. Now, minus a tenth. Now we have achieved the objective where the denominators are the same. Now we will take our numerator. Now we can be able to subtract our numerators. Therefore, we say 6 minus 1 equals 5. Can we subtract denominators? No, we cannot subtract denominators, class, because remember, a denominator represents the whole part of a fraction. So we will leave it as 5/10. But now here is the thing. 5/10 can be simplified. Why is that? Because we see except 1, there is a number that can go into 5 and also into 10 without leaving any remainder. In this case, the number that can go in both of these numbers, we see that the number is 5. 5 goes into 5 once, and then 5 goes into 10 twice. So we see that 5/10 is equivalent to a half. This typically is what we have covered in grade 6. Remember, guys, we started where we had 3/5 minus a tenth. and then one of the denominators was the multiple of the other. Now let us move to grade 7. In grade 7, we take a look. In grade 7, grade 7s, we are now going to focus again on the denominators first. But we can see that the denominators are not the same. That is number 1. Number 2, the denominators, one of the denominators is not a multiple of the other. Now what to do in this case? Because we know from grade 6, where one denominator was a multiple of the other, our focus was to change the one to be equal to or equivalent to the one to the other one. But in grade 7, things are changing. Now, these two denominators, they are not multiple of each other. So what do we do in this case? Rule number 1, open the bracket, put the first fraction on this bracket, leave a space enough, close the bracket, put the sign as is between the fractions, which is a minus, and then open another bracket, put the second denominator, put the second fraction, and then leave a space and close your bracket. Now, this is what is going to happen. On this bracket, we're going to multiply with the denominator of this side. Meaning, we are going to say 3/5 multiplied by 8 out of 8. Where is this 8 coming from? It is a denominator of this other side. Now, on this one, we are going to multiply by the denominator of this other side. So we're going to multiply by 5 out of 5. Right? Now let us begin. Working the BODMAS rule, brackets first. So we'll start numerator multiply by numerator. 3 multiplied by 8 is 24. Out of 5 multiplied by 8, this will give us 40. Minus, we take them outside the brackets because we already worked them out. We come to this other side. 3 multiplied by 5, this will give us 15. Out of 8 multiplied by 5, this will then give us 40. Voila! Can you see now our denominators are now the same, which makes it possible for us to be able to continue to solve our fraction. Now, since the denominators are the same, we are going to only subtract what? The numerators only. So we'll start 24 minus 15. This leaves us with 9 out of 40. Remember, guys, again, we are not going to do anything with our denominators. We cannot subtract the denominators. Our focus will only be on the numerators, where the denominators are the same. If the denominators are not the same, our mission, first number 1, we open the brackets, both sides. We write the fractions as they are given to us. This one comes here as is, and this one comes here as is. Now, after that, we take the denominator of the other fraction, multiply by that denominator on this other side, and then we take the denominator of this one, and then we multiply by it on this other one. This is typically what we are doing. Now, This is how we deal with the fractions where one denominator is not a multiple of the other. Right. Back to my presentation, guys. Now, let us see. We've already worked out those two. I've got others where we are adding and subtracting fractions where one denominator is not a multiple of the other. Example, we've got 2/3 plus 1/5. Now, let's work it out again the way we did with that one where we were explaining. So we've got 2/3 plus 1/5. 2/3 plus 1/5. Rule number 1 again. You remember, guys, we said we're going to open a bracket, write 2/3 inside this bracket, close this bracket, leaving a space. Then we add, the sign there was supposed to add, then we open another bracket, then we write a 1/5, then we leave a space enough for us to put something, then we close the bracket. So these fractions came down as they were. Remember, guys, after having done that, what I said is that on this side, we are going to multiply by the denominator of this other side. So we will say multiply by 5/5. This arrow represents the whole fraction. Then this one, it only represents this one. Right? Then, on this other side, we will multiply by the denominator of the first fraction, which is now 3/3. Then we start. Then we say, right, 2 multiplied by 5 gives us 10. All out of 3 multiplied by 5 gives us 15. We're supposed to add 1 multiplied by 3 equals to 3 out of 5 multiplied by 3 equals to 15. Voila. Now we can see our denominators are the same now. Remember, the mention is that we make sure first that our denominators are the same before we can add numerators. Meaning, we cannot add numerators if the denominators are not the same. Or vice versa, we cannot subtract numerators if our denominators are not the same. Right. Now let us make our basic math. So we'll say 10 plus 3, that gives us 13, adding our numerators because our denominators are the same, then it will leave it as 15. So our final answer is 13 out of 15. Now the thing is, can we be able to simplify this fraction? No, because the number that can go in both of these numbers without leaving anything is only 1, and 1 can only bring us to the same fraction without changes. Right? Let us move to this one. Now, again, this is just a repetition. Guys, we've got 3/4 minus 2/6. Somebody may decide to, you are welcome to simplify or write the equivalent of 2/6. Or you may leave it as is and work out the solution. Now this becomes, open the bracket again, first thing. Why? Because denominators are not the same. We cannot subtract numerators. So we must first, our first mission is always to make sure that our denominators are the same first, so that we can be able to subtract the numerators. So to make sure that our denominators are the same, we open the bracket first, we write the fraction as is given from the question, then we leave a space, then we subtract because we're supposed to subtract from the question, we open another bracket, then it is 2/6 as is, we write it. Then we remember again, guys, we said on this other side we'll multiply with the one that is given on the other side. Then here we will multiply with this one that is given on this other side. Therefore, 3 multiplied by 6 gives us 18 out of 4 multiplied by 6 gives us 24 minus 2 multiplied by 4 gives us 8. Then 6 multiplied by 4 gives us 24. Denominators are now the same. Now, if the denominators are the same, we may now subtract the numerators. 18 subtract 8, this leaves us with 10 out of 24. So our final answer becomes 10 out of 24. Now, in this case, we can be able to simplify this fraction. Again, it is simple. We just observe the numerator and the denominator and check whether is there a number that can go into a numerator without leaving a remainder, and also go into the denominator without leaving a remainder. So in this case, we see that except 1, again, remember guys, we cannot use 1. Now we can see that 2 can go into these two numbers without leaving any remainder. Now 2 goes into 10 5 times, and then 2 goes into 24 12 times. Or this is the same as that you have divided by 2 both sides. This then gives you 5 out of 12. Hoping guys you are still with me. Now let me continue. Right. Fractions can also be in this way given to us to solve them, where it says the question would be find the difference between 2/3 and a half. It says find the difference between 2/3 and a half. Now we are asked to find the difference. So remember guys, we've got our own vocabulary in mathematics. When it says find the difference, it means that which sign must we use? We have to what? We have to subtract. The difference means that you must subtract. Now, if it says find the difference, it means you have to subtract between the two fractions. Again, can you be able to subtract the numerator from this numerator to this one? The answer is no. Why? Because remember, the denominators are not the same. Now, if the denominators are not the same, what do? We apply our golden rule. We open the bracket. Then we put the fraction as it is given to us. We leave a space. We close the bracket. We write the sign as it is supposed to be. We open another bracket on this other side. We write the fraction as it is given to us. And then we close the bracket. Now, we remember guys, we said that on this other side, we will multiply on the both of these fractions. But on this side, we'll multiply with the fraction on the other side, which in this case will be 2 out of 2. Then this one, again, we said we'll multiply by 3 out of 3. Simple. 2 multiplied by 2 gives us 4. 3 multiplied by 2 gives us 6. Then we minus. Remember the sign is still minus. 1 multiplied by 3 is 3. And 2 multiplied by 3 equals to 6. Right. Then we solve our fraction. Right. Now our denominators are the same. Meaning that it now allows us to subtract the numerators. Then we'll say 4 minus 3, this gives us 1. So our answer is going to be 1/6. This is then our final answer in this fraction. Remember, the question said find the difference. We said when it says find the difference, it means that you have to subtract. Then we did put the sign as it was between the two fractions. Then we open the bracket, apply our golden rule, and we write this whole fraction as it is. We put it here. Then we multiply. And then remember, we said we'll multiply with the denominator of this other side on this one side. Then we minus, we open the bracket, we write the fraction of this side as it is. And then remember, on this side, we will multiply with the denominator of the first side. There we go. So the 2 multiplied by 2 gave us 4, and the 3 multiplied by 2 gave us 6 when we were simplifying the brackets. Bottomless rule. Minus, again, 1 multiplied by 3 gave us 3, 2 multiplied by 3 gave us 6. Now we were able to subtract the numerators. Why? Because the denominators were now the same. Right. Sometimes, guys, our fractions can be complicated. Like in this way. We can be given fractions where we're supposed to calculate a third plus a half minus a quarter multiplied by 2/5. So it is given to us that we have got to calculate a fraction like this. Guys, rule number 1, when it is like this, it appears as if it's complicated. Again, basically, what does this say to us is it reminds us of what we know, that we have to always not forget that in mathematics, we always work according to BODMAS. Now, BODMAS says that we have to start with the brackets. As we see that in our fraction, there were no brackets, then it says we have got to work with orders. There are no orders. Division, there is no division. It's addition, subtraction, and multiplication. Then, BODMAS tells us that we should multiply. In the absence of all the first 3, then we have to multiply. But we can see that in our fraction, there is a multiplication sign between the two fractions, which means we may now put our imaginary bracket, because we're going to start with this where we multiply, because BODMAS says we should multiply now. Then we open and close the bracket, because we're going to start with these ones where we're supposed to multiply. Then the question is, what happens to the others? The others, a third plus a half, they are going to still remain as they are. We'll drop them down as they are. So we'll say it is equals to a third plus a half, and the sign minus, we leave it as is. Then we work out these two brackets where we're supposed to multiply. Then we say 1 multiplied by, remember when we multiply brackets, denominators do not have to be the same. We multiply a numerator by a numerator and denominator by a denominator. So we will say 1 multiplied by 2 equals to 2. And then 4 multiplied by 5 equals to 20. Now we have solved this one. We have solved this one. Meaning we said 1 multiplied by 2 gave us 2. Then we said 4 multiplied by 5 gave us 20. Objective number 1, achieved. Voila. Now, we will move to the next one. BODMAS again. BODMAS says now, if you are done multiplying, now you have to what? Add. Now we check the fractions that are supposed to be added there. Do we have addition sign? Yes, we do have an addition sign. Now we have to add. Again, these you may put them inside the bracket. Now we are supposed to add these two fractions. Now when we add these two fractions, again, we may not, remember guys, let us get back quickly. We may not add numerators if denominators are not the same. The rule is still the same, that when you add or subtract, numerators cannot be added when denominators are not the same. Right, let us see why. Let us work it out now. Remember, we've got our golden rule. If denominators are not the same, we open the bracket, we say a third. We will multiply by this one because it's on this other side. 2 out of 2. We close the bracket, it's supposed to be added, we say plus. We open another bracket, we say it's a half. Then we multiply by the denominator of this other side. 3 out of 3. Then we close the bracket. Then we say, remember, this minus 20 will come down as is. Minus 2 out of 20. Forgive my language there. Minus 2 out of 20. Comes down as is. Now, remember, brackets, 1 multiplied by 2, we solve it, equals to 2. 3 multiplied by 2 equals to 6. Plus 1 multiplied by 3 equals to 3. This plus is this one, we are coming down with it as is. We don't change it, we don't forget about it. 2 multiplied by 3 equals to 6. Then this one still comes down as it is, because we are not yet going to subtract. Hence the BODMAS gave us the rule that we have to add first. Now, since now our denominators are the same, we may add our numerators now. And then 2 plus 3 equals to 5. Can we add the denominators? The answer is no. Big no. We cannot add denominators because they represent the parts of a whole. Now it equals to 5 sixths. 2 plus 3 give us 5, and then we may not add the denominators. Remember, we still have minus 2 out of 20. So say minus 2 out of 20. One step at a time. Now we are done, we go to BODMAS. Now the BODMAS allows us that we can subtract. Now, when we subtract now, we'll open, remember again guys, can we be able to say 5 minus 2? The answer is no. Why? Denominators are not the same. So we start opening the bracket with our golden rule. 5 sixths. We will multiply by 20 out of 20. Close the bracket. Minus, open the bracket. 2 out of 20. Multiply by 6 out of 6. Close the bracket. Then we say 5 multiplied by 20 equals to 100. All this is out of 6 multiplied by 20 equals to 120. Or there's another shortcut. Say just 5 multiplied by 2 equals to 10, then you add the 0 as is. Or 6 multiplied by 2 equals to 12, then you add the 0 as is. Minus 2 multiplied by 6 equals to 12. And then 20 multiplied by 6 equals to 120. Now our denominators are the same, as we can see there. Now we can subtract our numerators. So we begin 100 minus 12. This gives us 88 out of 120. Now, right. Now we see that this fraction can be simplified. Now we can simplify this type of fraction. But guys, let us be careful on that. We'll have to, when we work the solution on our question papers, check what are the requirements. Sometimes the question paper may say leave your answer as is, or you may simplify your fractions. But in this case, let us simplify our fraction. Now we ask ourselves, what is the biggest number? The biggest number that can go into 88 and also into 120 without leaving any remainder. 2 can go into this, but it is not the biggest number. So 4 can go into this, but it is not the biggest number. So the biggest number there that can go into those two numbers is 8. Right, 8 goes into 88 11 times. And then it goes to 120 15 times. Therefore, our answer there is 11/15. Right. Right, guys. The last part on adding and subtracting fraction is a word problem. Remember, guys, learning those skills and concepts along the way, we are learning them so that we can be able to now read the problem and be able to come up with a solution from what we have learned, from the way in which the concepts are supposed to be dealt with. Now, say for example here in the word problem it says, Tiamo have a half a liter of orange juice during break. She drinks 1/3 of that. How much juice is left? Now, Tiamo have 1/2 a liter during break of orange juice. If she drinks 1/3 of that, how much juice is left? Now remember, guys, we've got to be able to analyze this situation. Tiamo had a half. Now when you drink something, it means that it won't remain as half. It will get less. Now if it gets less, it means that there was a minus that took place there. So this means that if she had a half and she drank 1/3, it means she's no longer having a half anymore, but she's having an orange juice that is less than a half, meaning that we have to what? We have to minus, because the juice gets less and less as you drink it in the bottle. Now, we cannot say 1 minus 1. Why? Because denominators are not the same. How do we do it? Golden rule. Open the bracket. Write the fraction that is given to you. Multiply this fraction with a denominator of this other side. Close the bracket. Minus. Open another bracket. Write the fraction as it is given to you. Then multiply this fraction with a denominator of the first fraction. Then close the bracket. Then we go on, say, right now we work out the brackets. Where now we'll say 1 multiplied by 3 equals 3. 2 multiplied by 3 equals 6. Minus 1 multiplied by 2 equals 2. 3 multiplied by 2 equals 6. Now the denominators are the same, which means now we can be able now to subtract the numerators. 3 minus 2 equals to 1. Then we are left with 1/6. Therefore, we have to also respond to the question. Remember, we have done our calculations here, but check. The question says how much juice is left. So we'll say 1/6 juice is left. Right. Hoping, guys, you are still with me. Now, our next part now is to move to the mixed numbers. But before we get there, let us just do a quick recap. We have dealt with the fractions where one denominator is not a multiple of the other. We applied our golden rule whereby we said, okay, we cannot add or subtract denominators or numerators if the denominators are not the same. Particularly, our objective is to make sure that the denominators are the same before we can add or subtract. So in this case, we have covered those parts where the denominators were not the multiple of the other, and we had to apply our golden rule by opening the bracket, solving both fractions, then achieving our objective of making the denominators to be the same. After that, we then worked with our numerators, whether we were adding or subtracting. We were able to add or subtract them when the denominators were the same. If the denominators are not equal, you cannot add or subtract the numerators. You have your first mission is to make sure that your denominators are the same. Meaning, we take that rule, we open the brackets, we work it out. Now let us focus or move on to mixed numbers. Now first, what are mixed numbers? We say mixed numbers are numbers that have a fraction part and a whole number part combined together, called a mixed number. So we find out in a mixed number, it is that we've got a whole number standing on its own and a fraction next to it, which means now when they are combined, then they are called mixed numbers because there's a whole number and a fraction. For example, 3 1/4. 3 1/4, it is a mixed number. Why? Because 3 is a whole number and 1/4 is a fraction. Now, let us see how we can be able to calculate these whole numbers or these mixed numbers. Let us say, for example, we have 2 1/3 plus 1 1/5. We have 2 1/3 plus 1 1/5. Remember, guys, the denominators first are not the same, and these are the mixed numbers. Rule number 1, your mission is to make this an improper fraction. One might ask, what is an improper fraction? Remember, guys, we have dealt with the improper fractions in grade 6. Improper fraction is a fraction where a numerator is bigger than a denominator. In other words, the number on top, it must be bigger than a number at the bottom to be a improper fraction. So here, when we are faced or confronted with mixed numbers, our first objective is to change these mixed numbers into improper fractions. How do we do that? We take the denominator and multiply by the whole number, then we add the numerator. So we will say 3 multiplied by 2 is 6, plus 1 equals to 7. But the denominator will remain as is. We say plus, again, we will multiply a denominator by the whole number, and then we add the numerator. So 5 multiplied by 1 is 5, plus 1 equals to 6 out of 5. Now, we have improper fractions. We want to solve them because Our question was supposed to add the mixed numbers. Right. Now, since they are like this, we cannot add numerators. Why? Because denominators are not the same. We apply our golden rule that we learned from the fractions, whereby we will open a bracket, write the fraction as is, multiply this one with the denominator of this other one, close the bracket, then we put the sign was plus, open another bracket, write the fraction as it is given to us, multiply this with the denominator of the first fraction, which is 3 out of 3 in this case, close the bracket. Then 7 multiplied by 5, it's a matter of simplifying. 7 multiplied by 5 equals to 35. All out of 3 multiplied by 5 equals to 15. Plus, as the sign was plus, then 6 multiplied by 3 equals to 18. Out of 5 multiplied by 3 equals to 15. Voila, now we can see something common. Our denominators are the same, meaning that now we can add the numerators. Now let us add the numerators. 35 plus 18 equals to 53. All out of 15. Remember, guys, we cannot add denominators. Right, there we are. But now, remember, guys, our answer is now in a form of an improper fraction. But the question was given to us as a mixed number. So in other words, what do we need to do? We need to work it out and return it to a mixed number. Then how do we do that? We have to ask ourselves, because this one is bigger than this one, 15, it goes into this number how many times? Or how many 15s can we get out of 53? So there are many ways to do that one. Remember, in our introduction in grade 5, if it was like this, we were able to say, all right, before it came as 53 out of 15, it was 15 out of 15 plus 15 out of 15, checking whether we were 15 plus 15 equals to 30. Are we having 53 yet? No. We can add another 15 out of 15. 15 plus 15 is 30, plus 15 equals to 45. Can we be able to add another 15? No. Why? Because when we add another 15, it will give us 60, which is not this number. So, meaning that we must now add a number that will be, when we add these 315, give us 53. And that number is 8. We are running short of 8 out of 15. Now, remember, 15 out of 15 is equivalent to 1. Plus 15 out of 15 is equivalent to 1. Plus 15 out of 15 is equivalent to 1. Plus 8 out of 15 is not equivalent to 1 or equal to 1. It will stay as 8 out of 15. Therefore, 1 plus 1 plus 1 equals to 3 plus 8 15th. Therefore, our answer will be 3 and 8 15. This is a bit long route, but it was just a reminder that we have done something like this in grade 5. But in grade 7, it is assumed that you've got this knowledge, meaning that now we ask ourselves, 15 goes into 53 how many times? Now we count in the multiples of 15. 15, 30, 45. So it goes 3 times, and then it leaves a remainder of 8 out of 15. Now we have achieved our objective to leave our answer in a mixed number form. Remember, guys, it was, let me just write it here, it was 2 and a third plus 1 and a fifth, 1/5. Objective was to change this mixed number into an improper fraction. How did we do that? We took the denominator, we multiplied by the whole number, and then we added our numerator. Then it gave us 7/3. Plus, we took the denominator again, we multiplied by the whole number, then we added the numerator. Then it gave us 6/5. Then we said denominators are not the same. We apply our golden rule. Then it was a matter of us simplifying the whole fraction and then returning our answer into a mixed number. Hence, it was given to us as a mixed number. Right. Subtracting mixed numbers, still the same rule. What do we need to do? We need to change the mixed number into an improper fraction. 3, how do we do that? We multiply by the whole number, we add the numerator. We multiply by the whole number, we add the numerator. We always work it like this. Right. Then 3 multiplied by 3 is 9, plus 2, it gives us 11 out of 3. Then we say minus, then 4 multiplied by 1 gives us 4, plus 3 equals to 7 out of 4. Remember, we worked it out mentally. Hence, we've got our mental maths skills since grade 4, 5, and 6. Now it becomes easier for us to just multiply the numbers and add at the same time. Right. Now, remember, can we subtract these two numerators? No. Why? Denominators are not the same. What do we need to do? Apply the golden rule. What is the golden rule? Open the bracket, write the first fraction as it is given, multiply by the denominator of the second fraction, both sides, then minus, open the bracket, write the fraction as it is given, multiply by the numerator of the first fraction. By now we are mastering, I believe, guys. Then 11 multiplied by 4, Bottom's rule, 44. Mental maths. I love it. Love mental maths, guys. It gives us this quick way of doing our calculations. 3 multiplied by 4 becomes 12. And you guys have got this tendency of forgetting mental maths when you go to grade 8. Do not forget, guys. Mental maths will help you. 7 multiplied by 3, 21. See? Nice things about mental maths. 4 multiplied by 3 gives us 12. Halala. Now, denominators are the same. We have achieved the first objective. After having achieved the first objective, what do? We know we just subtract the numerators. Now we are allowed to subtract the numerators. Why? Because denominators are the same. Now, 44 minus 21. Again, guys, mental maths. These are the skills that come with mental maths. You are able to count the numbers mentally fast. For those of us who are still struggling, guys, this is what we can do. We can just on the other side do our calculations and say, okay, 44. Remember, guys, I like numbers when we maintain social distance between our numbers. Why? Because we want our numbers, our workings to be as neat as we are. Because we are always neat when we go into our schools. So we say minus 21. Remember, the units must match the units and the tens must match the tens so that everything is good. And when you have written your numbers, maintaining a social distance, it becomes neat and very nice. And it does not even confuse you. So you just start with the units. We work from the units towards your tens, hundreds, and thousands. Now, 4 minus 1 gives us 3. 4 minus 2 gives us 2, which means our answer there is correct. Then remember, we cannot subtract denominators. Again, now we are confronted with the same problem again. Now, It is an improper fraction. How do we identify it as an improper fraction? Because the numerator is bigger than the denominator. What do we do in that case? We ask ourselves, or we ask 23, how many times can we get 12? Or 12 goes into 23, how many times? So to put it simple, we just ask ourselves, how many times does 12 go into 23? In this case, 12 goes into 23 once. So that one, we start with it. It goes into 23 once. Now, we want to see, out of 23, when you take 1/12, how much is left? So we are left with 11 out of 12. Remember, guys, don't forget, you are still simplifying, and your answer must always be in a mixed number form. May not be more than a mixed number. So it has to be like in a mixed number form. We said 12 goes into 23 once. So this one comes here. If it was to go into 23 3 times, then here it would have been 3. The last part, guys, is for us to multiply the mixed numbers. Now, when we multiply the mixed numbers, guys, remember, the same objective that we were using for when we were adding and subtracting common fractions and mixed numbers, it could be applicable as well. Let's take it for example. We've got 2.5 multiplied by 1 2/3. First objective, guys, remember, change this mixed number into an improper fraction. 2 multiplied by 2 is 4, plus 1, 5. Out of 2, don't forget the denominator is always going to remain there. Then we say we're going to multiply. 3 multiplied by 1 is 3, plus 2 is 5, out of 3. The denominator remains there, guys, don't forget that. Right. We said 2 multiplied by 2 is 4, plus 1 gave us 5, out of 2. Multiply by 2 multiplied by 1, 3 multiplied by 1, 3 multiplied by 1 is 3, plus 2 equals to 5. Now 5 multiplied by 5 gives us 25. Out of 2 multiplied by 3 gives us 6. Right. Now, here is the thing. It is an improper fraction. Remember, our question was in a mixed number form. Now we need to return this to a mixed number. How do we do that? We ask ourselves, 6 goes into 25 how many times? Let us count in 6. 6, 12, 18, 24, 30. So 30 cannot work. So it goes how many times? 4 times. It is 6, 12, 18, 24. So it is 1, 2, 3, 4. So it goes 4 times. So 24, after we take 4 6s out of 25, we are left with 1 out of 6. So our answer is 4 and 1/6. And you can double check whether your answer is correct or not. How? You just take the numerator, you just take the denominator, you multiply it by the whole number, you add the numerator. It must give you this number. If it does not give you this number, it means something somewhere went wrong. So 6 multiplied by 4 is 24, plus 1 equals to 25, which is this number. Voila. Now we are completed. Right, guys? Unfortunately, we are coming to the end of the lesson. I thank you for being with me, for being a wonderful audience, and I'm hoping that we're going to learn something out of this. Again, I will urge you guys to please redo what I've done with you on your own. You see, maths, normally things becomes nice and easy when we do them together. You only get to learn them when you do it alone. Do it, practice it, and you shall get it. And I believe you that we are going to make it 100% this year. Thank you, guys. Thank you, thank you, thank you.